Going deep. So get ready, strap in. I've got an hour, 90 minutes, and I've got a ton of stuff to cover. If you've never seen Windows Azure, you're about to get bombarded with Windows Azure, and I apologize if that didn't meet your expectations coming into a deep dive session. And I also give you permission to stand up and walk out if this is not the session that you think that you wanted to come and see. That said, see if anybody walks out now, and we can make fun of them for being wimps and not being able to handle it. But, okay, so that said, let me just briefly tell you about my background in Windows Azure. I've been in Windows Azure for 3.5 years, like I said. I came from Windows. I work as a technical fellow architect in the Windows Azure group. I was the head architect for Infrastructure as a Service. Infrastructure as a Service, which is the ability to run stock server VMs in a cloud environment, is a feature or is a release that we made public, went to general availability back in April of this year, after a year of preview and after a year before that of development. So this has been a journey for us to get to the point where I'm showing you here, and there's been a number of feature releases since April. We're moving fast. We're by no means done with this set of features that I'm going to be showing you here, but this is a snapshot of where we are and the capabilities we've got, which I hope you'll see are pretty capable at handling even tier 2 type workloads. I mean, tier 1 workloads really aren't workloads for the cloud at this point, unless, at least the kind of traditional server workloads. So let's get started. Let's see if my clicker will click. Oh. So this is the agenda that I'm going to be covering. I'm going to be first talking about deploying virtual machines. We're going to go and deploy a virtual machine using the portal so you can see that experience. Then I'm going to talk about the storage architecture of Windows Azure virtual machines. What is underneath these VHDs, and what's the difference between an image and a disk, and how do you create an image, and what's the performance of our disks, and how do you optimize performance? I'll be covering some of those things. Then I'll talk about high availability. How do you stand up several VMs in the cloud, like a SQL always-on cluster, failover cluster, and how do you make that highly available using the features that Windows Azure provides you? Talk about networking features. How do you do load balancing across virtual machines? How do you connect directly to a virtual machine? How do you ACL endpoints to secure virtual machines? And then finally, I'll wrap up with hybrid networking, because most environments these days are hybrid, especially when you're talking about traditional virtual machines like we are here. You want it to connect back to your enterprise network. And there's a few offerings we've got there for connecting back to enterprise network. We've got what we call site-to-site VPN, and we've got point-to-site VPN. And I'll be showing you those features there. I'll be using a little bit of PowerShell, but mostly I'll be in the GUI, just because the GUI's more convenient. How many people have used PowerShell before? How many people consider themselves a PowerShell expert? Okay, that's the way it normally goes. It's like, for me, PowerShell is not, I don't do PowerShell every day, so every time I pick it up, it's like after a few weeks, I'm like, oh, what was that again? And then for the next day, I go around doing verb noun everywhere. Like I get up in the morning, I'm like, open car door, kiss wife, turn on radio. And then I start to think, wow, if these things were Windows Server objects, would I have to patch them? Like my wife, would I have to patch her? And then that distracts me all the way to work, and then I'm there. So this is the power of PowerShell for me. But I eventually pick it up, and I know it just enough to do wheres and selects and measures and things like that. So I'll show you a little bit of that too. This is, though, the way you get started with PowerShell in Windows Azure. It's incredibly simple. You go to that web page right there, download the Windows Azure PowerShell commandlets. Then you have to import your publish settings. So you log into the Windows Azure portal, run that commandlet right there, and it'll automatically download credentials and store them away so that PowerShell, from that point on, is aware of your subscription and automatically authenticates, and then you can just run PowerShell commandlets against that subscription. So I've already done that on my system, so you'll see me just running PowerShell commandlets against my subscriptions to show you things. Let's talk about deploying a virtual machine, and I'm going to start by going to the portal and giving you a little quick tour of what's up in the portal. For those of you that haven't seen the Windows Azure portal, This is the interface. It starts with an all items. So these are all the resources that I've created, and you can see I've got quite a few of them. In fact, I've got 3 pages of them. Then it's organized over here by resource type: websites, virtual machines, mobile services, cloud services, and so on. We're going to be spending our time in 3 of these areas today. One, virtual machines, of course. The other one, cloud services. And finally, down here, networking. These are the 3 that are related to Windows Azure Infrastructure as a Service. This one might be surprising to some of you because our marketing people have done a good job of trying to convince people that cloud services are PaaS, but cloud services really are a different kind of, they're an object, a container in Windows Azure. And so whether you're using virtual machines or whether you're using PaaS, you're going to run into cloud services, and I'm going to explain to you a little bit later the implications of having virtual machines grouped together in a cloud service. To create a new resource, this new bar down here is always there at the bottom, and we'll let you create all these different resource types. We're going to create a virtual machine. We're going to create it from the gallery, and I'll talk about what galleries are in a second. You can see that it's a list of operating system types. Now, one of the operating systems up here is the best, right there. Actually, this one is the best, and this one will turn to the RTM in a couple days when we officially release Windows 8.1 as well as Windows Server 2012 R2. So we will have those images up here in Windows Azure that concurrently with that. You'll also see, kind of surprisingly, well, of course you can see SQL images too. We're going to talk about those a little bit later. You can see a number of Oracle images. We've got Oracle. We did a deal with Oracle, so they've got their images up here as well. And we've got stock Linux images as well, so we've worked with Linux distros to get these images up there. I have to just point out Ubuntu and give a shout out for them because this is one of the coolest things, I think, that I've ever seen. This is Ubuntu bug number 1. You know, for those of you familiar with Ubuntu, it's made by a company called Canonical with a kind of boisterous founder, Mark Shuttleworth, billionaire, just likes to like free software and pushing Ubuntu. He believes that he can actually make Ubuntu the platform for everything. But this Ubuntu bug number 1, you can see, well, I don't really like that. And when it comes to phones and tablets, I think this bug has solved itself, unfortunately. But we're working on that. But the cool thing about this is if you go down here and you say, well, see Mark's closure comment. So Mark Shuttleworth himself closed this, and this bug comment, he says, well, basically you read this, he says, well, you know, Linux hasn't really taken over everything. It's not like it's got total market share. At least Ubuntu doesn't. If you look at Android, though, well, Android's taken over the world in phones and tablets. But then he talks about the cloud and how Ubuntu is useful in the cloud. And he says, it's worth noting that today, if you're into cloud computing, the Microsoft IaaS team are both technically excellent and very focused on having Linux, yes, like Ubuntu, run really well, making them a pleasure to work with. So that was just really cool to see. A shout out to not just Microsoft, but Windows Azure in Ubuntu bug number 1's closure, despite it kind of not being nice otherwise. Any case, so I'm not going to create a Ubuntu VM. I've already got one up there, but I will create a Server 2012 R2 preview one to take you through that process. And we're going to call this SQL Pass. You can pick virtual machine size. I'll show you a little diagram later that shows you the characteristics of these different virtual machines and how much resource they've got associated with them. Create a username. Create a password. And we, at this point, get the choice to create a new cloud service or add it to an existing cloud service. I'm going to add it to an existing one. I'm going to add it to the cloud service that I've named Mr. Linux. That is the one that I've got a Linux VM. And later we'll see the implications of me adding this virtual machine to an existing cloud service as opposed to having it in its own cloud service. Next, we get to, since I already picked a cloud service, it automatically populates the subscription that that cloud service is in, as well as where that cloud service is deployed. You can pick a region. Windows Azure's got 8 regions today, and we're constantly expanding. We've got regions that went live in China, for example. We've got ones coming online in Australia. So we've got actually Microsoft as a whole. Windows Azure is strategically a huge bet from Microsoft. We're actually spending close to $3 billion next year in CapEx for building out data centers across the world, that largely to power Windows Azure, so you can see that we're extremely serious about it. Now you pick a storage account. I'll explain why would you need to pick a storage account when you're creating a virtual machine a little bit later. An availability set, I'll talk about availability sets a little bit later. And then you get to pick what ports you want open on that virtual machine. And again, I'm going to cover that later when I get into networking. Now you press OK. And at this point, the virtual machine will start to get created. Somebody sets their stopwatch, or if you've got one. I want you to yell out at me in about 4 minutes, and then we'll see if we check on the progress of that thing. So if anybody raise their hand? Somebody raise their hand if you're going to do that for me. Okay, thanks. What happened underneath the hood? Let's go a little deeper into that. Is that Azure has pushed a bunch of information, has picked a server where to deploy that virtual machine somewhere in the farm of servers that we've got in the US East data centers, where we've got tens of thousands of servers. There's picked one, has pushed some configuration files down to that server, has created VHDs on that server, and has attached them to a VM that it then starts. Also, for an infrastructure as a service VM, we do something special, which is attach an ISO. So mount a CD-ROM, basically, virtual CD-ROM, inside the virtual machine. There's a provisioning agent in that virtual machine. We do a standard unattended install. The provisioning agent launches, and then that username and password that I configured, actually, that's what the provisioning agent injects into the virtual machine, sets the computer name, does a reboot. It's a sysprep specialized standard Windows installation. And we're going to take a look at that in a minute. But the overall flow is you create a VM. There's a platform image. Those are stored in Windows Azure Storage. Again, don't worry about that now because I'll come back to it. It copies that image into your own storage account. This is why we had to specify a storage account. Generates the ISO, then calls something called the Fabric Controller, which is what's responsible for deploying VMs. Creates an infinite lease, which is basically saying, I own that blob, that VHD. Nobody else can delete it out from underneath this VM because that would be bad for the VM. So this is what Windows Azure has this concept of leases on storage objects to prevent them from being destroyed while somebody's using them. Creates tenants, adds images, talks to what we call the host agent inside the VM, running on the hypervisor, downloads the ISO, creates the VHDs, like I said, starts the VM. Notice that it says something called, it does something called prefetch cache VHD. I'll explain that in a minute. And then connects with the IaaS disk driver. There's a driver inside the running in the host partition that is responsible for connecting the disks of that VHD to their backing store. And then we go through the unattended installation, specializing the image, creating the page files, and so on. Take a quick look at the provisioning ISO, in case you're curious. Has anybody done unattended installs of Windows before? Let's see, raise your hands. Anybody? So you're familiar then with this file. I've got the unattended ISO right here. This is an actual unattended ISO that was attached to a particular VM, a test VM that we deployed. And here, if you go into OEM, there's the provisioning agent right here that gets run. Here's the unattended file. And kind of standard things. I do want to point out a few things as we go through here. You can see it configuring the time zone, setting the BCD file. It also sets the RDP timeout. So these are some things that you should be aware of that we do for you when you create a VM through the provisioning experience. I'll take questions at the end. If you upload your own VHD and haven't done these things, this is something to be aware of that you might want to go configure. For example, if we go to operating system, you can see that here's where we set the administrator account, where we rename it. We're using all WMI here, setting the page file, and the page file is put on a special disk, which I'll explain in a minute. We configure automatic updates. This is different than Amazon, you should be aware of. We want you to be secure. So one thing we do is every month we update the IaaS images in our gallery so that there are the latest fully patched versions. You're not going to be downloading a whole bunch of stuff from Woo the second you deploy. We also configure automatic updates by default. Yeah, question back there? 4 minutes. OK, let's go try. So where's that VM? What did I call it? SQL Pass. There it is. SQL Pass. So we're going to download an RDP file. Let's see if this comes up. And looks like we're good to go. What we need to do. At that point, got the RDP thumbprint. Again, part of that unattend is connecting, and there we go. So less than 4 minutes. In fact, it's going to be between 3.5 minutes to 4 minutes, even though the portal said it's still provisioning. In fact, let's go back and take a look at the portal. If we look at the status, an update is in progress. So this is something we're fixing, is making the portal reflect the true time when the thing is ready. Here it is, SQL Pass. Oh, now it says it's running. But about a minute and a half before the portal says that it's ready, it's actually ready. So I want you to look at that. If you're looking at competitive clouds, you're going to see that we have by far the fastest Windows deployment by good margin of any of the clouds. And I'll tell you a little secret of how we're doing that. There's 2 optimizations we make. One, so sysprep specialize. We go through the specialized process, like I said. But there's 2 optimizations that we reduce the time for the Windows part of it, as opposed to the pre-part, which is creating the VM, and the second part, which is the connecting back and getting the RDP file and so on, to about 2 minutes. One, we persist driver installation when we sysprep specialize, or sysprep generalize. There's a little flag on sysprep that you can set. You should do this on your own images you upload. What that does is says that these images, these drivers are part of the baked-in image, so they don't have to get installed afterwards. They're pre-installed, and because we're running on virtual hardware, the drivers for virtual hardware don't need to change, and so this is an optimization that's just a no-brainer for running on virtual hardware. The other thing we do is a secret sauce inside of Azure, where we, for our own images that we upload, we do a prefetch optimization. This prefetch optimization, for all our images, we run them in the lab, we boot them. Over here, you can see in the build lab, we've got a prefetch monitor that's watching the blocks that the VHD is pulling in. And then we generate a prefetch file. You can see what's just really a map of the sectors that were touched. When the VM, before the VM boots, the prefetch driver goes and pulls those blocks down to the server and then lets the VM launch. And so all the data that it needs to boot is there. Now, this prefetch optimization kind of weakens over time as the image changes, as you apply more and more patches. But for the most part, we see that it holds up pretty well. And certainly for that first provision, it gets you this kind of really good performance. Overall, our performance targets are under 6 minutes for Windows and under 3 minutes for Linux. And we're well within that right now. And we are continue to try to drive this down every day. This is a weekly metric we track. I actually run the meeting every week. In fact, we had it Monday, where we look at the graphs of what we're doing. We talked about optimizations, and we make sure we don't have regressions. So we're really focused on making sure performance is good. Let's take a little bit more into images and disks now. So I mentioned that what we've got is all our images, all our Windows Azure IaaS artifacts, the VHDs, are stored in Windows Azure Storage. Windows Azure Storage is a REST platform. It's like Amazon S3, except we also use it as our VHD block storage. Amazon's got something else. It's called EBS, Elastic Block Service, or Elastic Block Service, whatever. We've got Azure storage for both. We get some benefits out of having Azure storage for both. One is that Azure storage is a highly available, highly reliable storage system. There is no data loss. Whenever a VM writes a block to its VHD, it gets triplicated in our data center before that write is acknowledged. This is especially important for apps like SQL, where they do a write-through write to the disk, and they expect that if the server crashes, that write made it back and is durable in storage. You don't want the VM coming back and then transactions being fragmented because some writes were lost. So that's one benefit we get, is we just automatically got that. It works with all REST storage APIs, and I'll show you that in a second, which is another huge benefit. You want to upload VMs to Azure, just copy them up into Windows Azure storage blobs. You want to download them, just copy them right down using the Windows Azure storage APIs or tools. Third-party tools work with them as well. One of the restrictions when you're using a blob for a VHD, for a VM, is it has to be in the same region as the VM. We don't want you getting crappy performance because you're going halfway across the world, your VM talking to its storage device. So we do that as a kind of guardrail for you. The images that you saw in that platform gallery, they're sysprep generalized images. So all of the Windows images are generalized. The Linux images, of course, Linux has its own deal with specialization and generalization, but they're all ready to go and be cloned. So the definition of an image is you can clone VMs from it. There's two galleries. One is the platform gallery, which you saw. And the other one is your own gallery. Now, I don't have anything in my own gallery. And you can also create VMs from disks, which I'll talk about in a minute. But as far as images, you can create your own images using the capture UX. So this is if you go into the VM, sysprep generalize it, and then go into the portal or use PowerShell. After you've sysprep generalized it, you run this commandlet or go through the portal or there's a REST API. That will go and take that image, take that VHD, import it into your My Image gallery, and delete the VM. And now you've got an image that you can go and stamp out new VMs from. So that's the way to go and create a baseline for deployments, scale-out deployments. When it comes to the images that we've got in the gallery, this is the official list of supported images. Important to note that when we say supported, that means not just that it runs, because there's lots of apps that'll just run, and these are just virtual machines for the most part. So as long as they don't have bizarre hardware requirements like 3 NICs or huge amount, 1 terabyte of RAM, they're going to just run. But when we say supported, we mean Microsoft support. You can call Microsoft support if you run any of these applications on Windows Azure, and they will answer the phone and help you troubleshoot the problem. That's not necessarily true for running these apps in other cloud platforms. So which is a place where we can kind of advantage ourselves a little bit. You can see all versions of SQL, 2008 and later, are supported. And I'll show you examples of us running SQL here. If you want to see the full set of images, and that UX isn't the full set of images, let me pull up the PowerShell here. So this is the PowerShell interactive editor, where we can run PowerShell scripts. And you can run this PowerShell get Azure VM image script. It will show you information about the images that we've got, including the category. So here's a SQL Server one, where it's located, which regions. Remember I said the VM has to be in the same region as the image. The disk size. So all of our disks for all of our platform gallery images are 127 gig in size. That doesn't mean you need to pay for all that, which I'll talk about in a minute. The label, the image name, this is what you would use when you're creating VMs using PowerShell, is this image name right here, and then a description. There's a total of, here I get to show my cool PowerShell skills, 126 images. And if we want to see which ones are SQL, there's the SQL ones. And there's, including these two right here, which are the latest versions, SQL Server 2014 CTP 2. Disks, let's talk about disks now. We talked about images, and you saw disks show up in that VM creation wizard. Disks are essentially specialized VHDs. You can create a VM from a specialized VHD. That is like saying, you know, when in a Hyper-V or VMware where you've got a VHD sitting around, you say, oh, create a VM. Oh, I've already got a VHD. It's right there. That's what these are for. And when you go and create a VM like we did, we're creating disks on the fly from the images. So these, when it gets specialized, it becomes a disk. You have to import them. This is a process of what we just saw in that gallery, where if we said my disks, you can add a disk to the system. Once it becomes added as a disk, it gets a special lease put on it, and it shows up in this list right here. It also shows up here in disks. So these disks are all the disks that I've created. Some of them are attached to VMs. You can see the attached to here, and some of them are not. The ones that are not, I can attach to another VM. And then if I want to create a VHD, this is the way you would import it. You can specify, here's browsing my storage accounts that I have access to. So I can just specify any blob, actually. It doesn't care at this point. So I could point it at something that's not a VHD. Then if it's an host OS, I tell the hypervisor which one to optimize for. And at that point, it gets imported into that disk's view. There's a couple of caching, or 3 caching modes that are possible for disks. And this is where touching on performance. There's read-write, there's read-only, and there's none. Let's talk a little bit about those. Read-write means that there's a cache on the server that's on disk cache, so that when the VM does a write or a read to its VHD, that data gets pulled in from Windows Azure Storage and then stored locally on the disk. And now when the VM reads or writes the same blocks, it doesn't have to go all the way to Windows Azure Storage, unless it's a write-through write. Then we do always send it back to Windows Azure Storage. Also, if it's a flush, then any dirty data in that cache gets flushed back, regardless of what the caching mode. Read-write, you can see, is the default for the operating system disks. And when you create a VM, you get one disk. It's the operating system disk with read-write caching. We have this default mode because operating systems do lots of small, random writes, and they have best performance when you cache that data because they're often writing to the same places over and over, and then they'll occasionally do a flush. But especially for boots, this caching mode gives the VM the best performance. You can see the default for data disk is none, no caching. So this means every write and read from the VM goes directly to Windows Azure Storage. I'll talk a little bit about why we chose that and tips on optimizing in a second. As far as disks, remember I showed you that disk that we created, that image, was a 127 gigabyte image. And if I go look in that VM that I just created, it's got a 127 gigabyte OS disk. And if you go look at Windows Azure Storage costs, you'd start to say, oh, a few pennies a gigabyte per month, and this stuff adds up. But you actually are not paying for all of that. You're only paying for the parts that get written to. This is a sparse storage subsystem, thinly provisioned. So you write a block, at that point you're paying for the block. The rest of the disk that's empty, you've never written to, free. Up until now, we had this situation where as the VM lives its life and it writes more and more, eventually Windows deletes stuff and adds stuff and deletes stuff and adds stuff, and you end up writing eventually to almost the whole disk. If you let it live long enough, you've probably populated the whole thing, even though the in-use part might be relatively small. So it's kind of this buildup of cruft. So I wanted to announce one thing here, so I said, please let me announce this here to you guys so you could feel like you're special. And I feel like I'm special announcing something. Trim support. So 2 weeks ago, we rolled out trim support. Now, what does that mean? Well, trim support enables an operating system to let the storage system know when it's deleting stuff. And then the storage system can say, oh, you're deleting it? Well, then I don't need to worry about it anymore. This trim command was created for SSDs. SSDs have block sizes that are larger than disk cluster sizes. And so when OS writes to a SSD, the SSD has to do a read of the whole block and then write the part that the OS is writing on top of it. And that's costly. And so if the SSD knows that the operating system's never written to that block, then it just can let the write go through and doesn't have to do the read of what was originally there. So this is a performance optimization, and it also helps with wear leveling. We take advantage of that here to let the VM know, hey, we've got trim capability, and now the VM lets us know when it's deleting stuff, and we clean up those pages in the blob underneath, and so now you won't have that growing cruft. Couple caveats here as far as operating system support. Windows Server 2012 and Server 2012 R2, trim works on the OS and the data disks that you attach to your VMs. With Server 2008 R2, it works only on the OS disk, and for Linux, right now, it doesn't work on any of them. We're working with the Linux vendors, though, to get trim support into their distros up in Windows Azure. The reason that you see this difference between Server 2012 and Server 2008, by the way, is that trim is supported only on ATA disks in Server 2008 R2, but in Server 2012, but in R2, we added support for SCSI disks as well, and those data disks appear as SCSI disks inside the VMs. So that works now. So exciting? Is that exciting to anybody? Exciting? Yeah? Feel special that I announced that here? As far as VM sizes, here's a matrix of those VMs, the VMs that we've got in production. This is the drop-down that you saw. The cores, the RAM, and the data disks that you can attach to them. Based on the size of the VM, that determines how many data disks you can add to the VM. A disk can be up to 1 terabyte in size. You can see that with these larger VMs, extra large, 8-core, 14 gig, and our A7 size, which has 8 cores and 56 gig of RAM, you can add up to 16 disks. I've created a PowerShell script that creates a VM here with a whole bunch of disks. You can see this is the PowerShell command. First thing you do is create an object called VM-config, and that's where you say what size you want, what name you want, what image, and here, by the way, is the image, which is the latest data center preview image. And then you pipe that through to, well, here's the provisioning config, which is the, hey, it's Windows, here's the password, and that's not really the password I used, by the way. And then you add the data disks to it. You can see I've pipelined a whole bunch of add data disks. If you count them, there's only 15, though. Let's go and take a look in the portal. If we go to virtual machines, and I've got my IaaS 16 terabyte here, and down here you can see OS disk followed by a whole bunch of data disks. If we connect to that, and I've just created this morning, so these disks haven't even been seen by Windows yet. So when I run disk management, you're going to see Windows ask me to create partitions on them in a second. And then what I'm going to do is add a disk to it. Apologize for the delay here. Okay, that's not a good sign. Oh. I guess connection quality is not good. I've never noticed that before. Wonder what that does. Oh, okay. By the way, anybody know about Window Key X? Yeah, it's my savior. Window Key X is the power user menu in new versions of Windows. You can see here it's saying initialize the disks. And when we look at this, you'll see that there's disk 0, that's where the operating system is. Then you see disk 1, temporary storage. I'll come back to that in a minute. And then you see down here lots and lots of disks, but there's only 15 of them because it goes up to 16, but the numbering starts up here at 2. Adding a disk is as easy as doing this. Attach disk. And so you can attach an empty disk, or here's where you can attach another disk. I'm going to attach an empty disk, and I'm going to make it 1,024 gigabytes. Unfortunately, we've decided that 1 gigabyte is 1,023. 1 terabyte is 1,023 gigabytes for some reason. I had nothing to do with that. And so let's go create that. And in a few seconds, so roughly 30 seconds or less, we're going to have Windows pop up and say, hey, you've got another disk. Oh, am I in the right one? Yeah. Well, no, that's the VM that I created before. Here's the one. So in a second, disk 17 is going to pop up. And let's come back to that and after I talk a little bit more about the disk subsystems, because we saw that temporary disk. What is that temporary disk? Here's the storage architecture underneath one of our VMs. A virtual machine, we saw the COS disk. We saw these data disks here. They get drive letter E and so on. And then D we saw, which is the temporary disk. If you look underneath these two C, and D, there's a striped volume. This is on the server underneath the VM. There's a whole bunch of spinning HDDs under there. That's where the cache is located. And that is also where this dynamic VHD underneath this D drive is. This is a dynamic VHD sitting on the server. It's a throwaway VHD. In other words, if this server died and the VM gets reincarnated or moved to another server, it's lost whatever was there. That is where the paging file goes. You don't need the paging file if the server dies. The paging file is for paging and also for crash dumps. When the VM crashes, you get crash dump saved to the paging file. And then you can see the local disk cache is also there. There's some implications of these VMs sharing these spinning disks because there can be other VMs also sharing the stripe. You can see that with the none caching, which I've got on these data disks here, no touching of the local HDDs, just directly going over the network to Windows Azure Storage. So when it comes to disk performance, here are some limits to be aware of. The number of transactions for a storage account, up to 20,000 transactions per second. And then there's bandwidth ingress and egress into a storage account. So if your VMs are transferring huge amounts of data or you got many, many VMs using the same storage account, you could actually run up against these kinds of limits. And then as far as performance, for no caching disks, we've got an IOPS target of 500 IOPS for IOs of 64K and less. Right now this is not capped, but it will be capped shortly. Right now you'll see performance exceed this value sometimes, but it's going to be capped shortly to give you 500 IOPS, which will give you consistent performance across your VMs and across your disks. The temporary disk, like I said, you lose that when you change the VM size, when the server fails. Be aware that if you're storing cache data, that you can use it as a cache, that VHD is a dynamic VHD. It starts out with no size, basically. And as you write to it, the VHD expands. If you've ever watched a VHD expand, you know that it's not the fastest thing in the world. There's a whole bunch of file system metadata and VHD manipulation going on that causes VHD expansion to be relatively slow. Your throughput will tank as you expand the VHD. So when it comes to disk performance, let's take a quick look at disk performance. Let's actually take a look. We've got our 17th disk there, and there it is. And then one of the things you can do here, we've got 16 1 terabyte disks. I can create a new spanned volume that consists of all of those disks. And now I will get, in the end, and by the way, be sure to check this. And in about 30 seconds, I will have a 16 terabyte disk attached to this VM with the target IOPS of 8,000 IOPS, 500 per disk. By the way, of course, you're all SQL experts, but I've been told don't use Windows striping or spanning for SQL. Let SQL do its own thing on the disk. Of course, that's another case where SQL's like, whatever, you don't know how to do it right, let me just do it for you when it comes to spanned. I created a spanned one. Well, if you've got enough outstanding IOs, then you'll get IOs hitting each of the disks. We'll talk about it later. I've got another VM which I've provisioned a little test tool in, which just quickly, because we're running a little bit behind. I've got till what, 11:30? What? Really? All right, let me speed it up. Actually, I'll skip that. Tips on optimizing disk performance. OS disk, best to have the read-write default. Temporary disk, be aware that it's local spindles that can be shared. Your performance is going to be variable. Make sure that if you're going to use it for storage and you care about performance, that you pre-expand. So you write to expand the dynamic VHD first. The data disk, great at random writes and large working sets, and a striped data disk is even better. Actually, so put it in a stripe and you'll get good performance. Unless it's small, so this is tips for people doing SQL. Don't put a big SQL database on your OS disk. You're not going to get great SQL performance. put big SQL databases on a data disk with no caching, and that will give you the best SQL performance. One of our, what we did is, of course, the SQL team is part of Microsoft, so we worked closely with them on making sure that the storage performance met the needs of SQL. And here's a little quick summary that you'll get when you get the slides about the way that our disk architecture works underneath our VMs. Let's talk about high availability now. Our SLA is 99.95% availability, but it comes with a caveat. It comes with a contract. It's a contract that you've got some obligations on your side to be part of that contract, and that is that you put your VMs in what's called an availability set. It also, for what it covers, it's the obvious things. It covers our inability to keep those VMs up. So if the network dies underneath the VM, if the storage dies under the VMs, if the servers die under the VMs, that counts against the SLA. If you do things like crash your VM, make your VM unbootable, that's your deal. Now, what's an availability set? An availability set, to understand what it is, you need to understand two concepts that we've got in Windows Azure. One's called a fault domain, and the other one's called an update domain. You can think of them as unplanned and planned outage control. A fault domain is for unplanned outages. A fault domain is to protect a collection of servers, VMs, against a single point of hardware failure, taking out all of them. In our data center architecture, we've got we've got several single points of failure. The server itself is a single point of failure for a VM. The top of rack router is also a single point of failure for a VM. So we consider that, and that's our top level single point of failure. So a fault domain maps to a rack. An update domain, which is for planned outages, applies for virtual machines when we update our infrastructure. We're running Hyper-V, stock hypervisor underneath with Server 2012, so we have to patch Windows underneath to keep secure and meet compliance. By the way, we've got FISMA compliance certified a few weeks ago. We're ISO, we're SSE 70, we're a whole bunch. But to maintain that compliance, we need to make sure that our infrastructure is patched. And when we patch, what we do is make sure that we don't take out all your VMs at the same time. If they're in different update domains, we will only take out the ones in update domain by update domain. Let's take a little deeper look at this. Now, I've got a highly available app up here in the cloud. It's an app that some of you might have some familiarity with. If I go to Cloud Services and I go to Mark SharePoint, I've got a SharePoint farm sitting up here. And that SharePoint farm, let me connect to it. Here, I'll show you the VMs in it. I've got a bunch of VMs. I've got 2 domain controllers, a SQL Server always-on cluster, 2 SharePoint front ends. Well, actually, this is the SharePoint app servers. This is the SharePoint front ends. And here's the SQL Server with always-on cluster with the Quorum server over here. You can see that we've seen what update domain and fault domains they're in. And when it comes to collections of VMs that are related to each other, we want them spread out into different update domain and fault domains. So these DCs, you can see they're in different update domain and fault domains. So they're in different unplanned and planned groupings. So when if our top of rack router fails, it's going to affect at most one of these 2. When we update the host operating system, we're going to take down at most one of these at a time, and then wait for it to come back up and be ready, and then move and update at some later point the server underneath the other one. Do the what? No, they don't. The Quorum server doesn't have to be the same size. You see these do, but these are the A6, big A6 servers. The question was, do all the SQL instances have to be the same size? The Quorum server doesn't have to be. Now, just to talk a little bit more about placement, if we take those front ends and put them in an availability set, we group them that way. They'll be placed in different racks and different fault domains, which are mapped to fault domains. And they'll be placed in, treated as different update domains as well. So that means that they're on different servers if they're in different update domains as well. So fault domains gets you on different racks. Update domains put you on different servers. And here's just another little pretty, I've got to show this, little graphic. So these are actually power unit rack switch is also another single point of failure. So when it comes to availability sets, you put them in an availability set, you're going to get those servers in different racks. And so if one rack fails, you're meeting that 99.95. When it comes to operating system updates, we do this about once a month. Your downtime is going to be 15 to 25 minutes. The downtime is the time it takes to shut down all the VMs on that server, and you get 5 minutes to shut down. The time to sysprep specialize a new OS image underneath on that host, and then bring your VM up. Now, the challenges we've got is honoring these update domains, which means that we've got to march through the data center in a very orchestrated way. And this makes it very hard for us to predict when we're going to be taking down a server. We also do the rollouts gradually to see if there's any problems. So for our multi-instance VMs, like ones in an availability set, extremely hard for us to know which kind of time window, even which day we might be doing it, because we're not updating the whole world at once. We'll do a few data centers, parts of a few data center on Tuesday, then we'll do some more on Wednesday, and so on. And based on how those are going, we'll get to ones later. One of our number one customer asks is, for my single instance VM, please let me know when you're going to service the host OS. Planned maintenance. We are piloting planned maintenance notification, and I've got some example emails. If you've been deployed on Windows Azure in the last few months, and then you've seen these emails come out. And they are right here. So maintenance, this is an email that went out a few weeks ago. Maintenance affecting a single instance virtual machine deployments. Oh, that's the complete one. That comes afterwards. Here's the pre one. Here, upcoming maintenance will affect single instance deployments. And then you can see that what we'll do is the single instance VMs, we know when those are going to happen because we do all the multi-instance ones. All the single instance ones we can do all at once or within a few hours. So we know when those are going to happen. And we plan for them. And so we give you these time windows here. And what we'll do is there's two regions that we pair together for geo replication of storage. We'll also alternate those in terms of updates as well. So North Central US and South Central US, the updates for them won't happen at the same time, and they'll have two different non-overlapping blocks of time. So if you've got an HA story across those regions, then you are sure that you're up, even if your single instance VMs go down in one region. And so those are the time windows that we've got here. And then you saw that we send out also this post update to tell you that it's now, that the maintenance is complete. We'll also tell you if for some reason the maintenance was delayed or whatever. And we're still in piloting that, we're still getting that down, but this is, our intent is to actually make that a rigorous part of what we do. Let's talk about networking features now. So when it comes to virtual machines, you of course have to name those virtual machines and they have to be discoverable. And we've got a few different options when it comes to DNS and discovery. We've got Windows Azure provided DNS. We've got, which I'll cover here. You can bring your own DNS, so you can launch your own DNS server. In fact, if you're going to stand up a SharePoint farm like we did, we've got our own DNS server there. You can also use a third party or an external DNS server, of course. As far as protocols in our networking, we support UDP, we support IP, we support ICMP, TCP, of course. And we've got a couple of features that are unique to Windows Azure. One's called port forwarded endpoints, and the other one's load balancing with custom load balancer probes, which I'm going to cover now. When it comes to a cloud service and Windows Azure, so every virtual machine exists in a cloud service. Even if I'd created a single virtual machine, it would have been deployed into a cloud service. So that's why I said in the portal, those are the two areas, big areas you're going to be working with, cloud service and virtual machines. The implications of being in a cloud service, there's several. One is that each cloud service has a single public IP address. An IPv4 routable public IP address is signed to the cloud service. So the logical question that you'll have at this point is, if you've got multiple virtual machines inside the cloud service behind a single publicly routable IPv4 address, how do I go talk to an individual VM? How did you RDP, Mark, into that one VM when there's only one IP address shared by both of those VMs that I had in that cloud service? And the answer is port forwarding. There's a load balancer that's sitting and maintaining that public IP address, and it projects to the outside world ports that then remaps internally. And this port forwarding is visible, for example, on these web front ends here in the SharePoint form. When I go to endpoints, you can see that I've got several ports. We're going to come to the web one last because it's a load balanced one. But this RDP one, which is one that we would use to RDP in, you can see that it's got a different public port and a different from its private port. 3389, that's the standard RDP port. So the server thinks it's listening on RDP. When I hit the public IP address, I'm actually going to be, to talk to that VM, to talk to this port right here, I have to hit the public IP address : port 57197. You can see that when I go and, where was that web apps one? Download the RDP file and try to connect. You saw it right there. Port 51 whatever, you saw briefly pop up. What was the password again? Oh. There it is, right there. And that RDP file you download automatically has that pre-populated. So that's something to be aware of. That's the way that we connect to that specific virtual machine. And so in a second, that's going to connect. Load balance sets are for load balancing virtual machines. Our SharePoint forms got these web front ends that need to be load balanced for high availability. They're also they're an availability set, of course, too. But to load balance them, I put them in a load balance set. And that's where you saw in the portal endpoints this web where the public port maps directly to the same private port. That just makes it convenient. And it's part of a load balance set called LB Web. LB Web, let's answer this. So I TS into the front end. That LB Web, if I say edit, you can see that it's a TCP port, public port, private port, and it lets me reconfigure the load balance set if I'd like to, where I can specify a number of different attributes of that load balance set. But one of the things I can see down here is which other VMs are part of that load balance set. So these are the two front ends for my SharePoint farm are part of that load balance set. Now what will happen is that the load balancer will spray requests across them. I'll demonstrate really quickly because I just think this is a cool demo. I've got a website called IaaS Load Balance Demo. And when I click on the public link here, the DNS name that's mapped to that, by default, to that public IP address, you can see that when I press F5, occasionally, well, all right. Okay, so normally this changes, but it's deciding not to. So the load balancer uses a 5-tuple to route requests. Source port, source, IP address, protocol, destination port, destination IP address. If any of those change, you're going to get routed to a different VM. So typically the source port changes as the browser creates new connections on the source side and gets new local ports, but it's not working. So but you can see up here I got routed to 30,001, VM 30,001. If I select, oh, you know what, maybe that's because, oh, there we go. It was IE autocomplete, sorry. So there, all right. Okay, never, yeah, all right. Here's how I can just make it do what I want to. And that's because I've got this thing, these 7 VMs behind a load balance. They're in a load balance set. but they've also got port forwarding configured on them too. So I can go to each one individually by hitting the port forwarded endpoint IP port on that public IP address. So that's a little demo. Normally, IE is more cooperative. If we were using Chrome, I bet it would work. No, you didn't hear me say that. All right, so let's talk about custom probes. So when it comes to VMs, sometimes we want the ability to have a custom probe. Now, for load balancer, part of the load balancer's benefit is not just the spraying across VMs, but also checking for health and taking the VM out of rotation if it becomes unhealthy. And there's a default policy for TCP where I don't have to configure anything. When I add the VM to a load balance set, if it's got an input endpoint on it, like this one does, it's got a public port, TCP port, what the load balancer will do is automatically hit that port every 15 seconds, and if it misses 2 probes, it takes it out of rotation. But I can override that with custom probes, which you saw the hint of when I went to, let's just look at one of these. So if I say edit, and then I say, yeah, reconfigure, then I can change the probe protocol from TCP to HTTP. If it's TCP, it just does a TCP connect, sees if the port's open and listening. If it's HTTP, it does an HTTP connect and waits for 200 to come back. And then the probe port, the probe interval, so you can take this down to 5 seconds if you want, the number of probes that you want it to miss before you decide it's unhealthy as well. And these policies are just going to get richer over time. We're by no means done with that, but that's what we've got today. We've also got something called access control list, which is relatively new. This came out about a month ago. There's no UX for it yet, though UX is going to be rolled out in a few weeks in the portal, but you can configure this using PowerShell scripts. So if you want some security, so you've got something sitting on the public IP address open to the internet, you want to lock it down, for example, only allow your CorpNet to access it through that public IP address, you can set an ACL. And the ACL rules, you can put up to 50 rules on the IP address, the port, the remote subnet, and the order. And it's allow or deny. And so some random guy coming off the internet won't be able to access your input endpoint. So this was a big ask that we had from people putting these things up. We've also got something called virtual networking. Virtual networking allows you to group VMs from different cloud services together inside of a network container. And this is where the relationship between cloud services and virtual networks is worth explaining. So virtual network, or so cloud service, when 2 VMs are in a cloud service, they can ping each other because they're part of their own virtual network that comes as part for free of being inside of a cloud service. If I go to this VM that I created in that Mr. Linux, that PAS, SQL PAS VM I created at the beginning of the talk, here it is. I think I'm already RDP'd into it. And so if I open a command prompt, and I ping that Linux VM that's part of that same deployment, so Mr. Linux, where is it? You can see that it's, over here, its public IP address is visible as well as its internal IP address. So if I ping that, it's going to reply. Because I'm part of the same cloud service, I'm part of the same virtual network. So at this point, the only thing protecting VMs of part of the same virtual network or cloud service from each other are their own firewalls. And Linux, by default, has no firewall policy out of the box, and so I'm able to ping it. If I try to ping a VM from another cloud service, and let me see if I've got any other Linux VMs up here. I don't think I do, but I do have this. Well, you'll trust me. If I try to ping something else in a different cloud service, it's not going to work if I go to that internal IP address because we're in our own virtual network bubble. So it can't even see those other IP addresses. Virtual network lets you bring your own IP addresses and overlay them on top of our IP addresses. So you don't like our 10 space? Bring your own. And once you bring your own virtual network, you can put other VMs into that virtual network from different cloud services. You can also assign different subnets to groups of virtual machines, which is useful because you might want a an IP address to be static, to remain stable. If you've got a DNS server up in your SharePoint farm, that thing needs to have a stable IP address. So you need to put the thing in a virtual network, and you need to put those domain controllers in there, one of them having a DNS server role probably, in its own subnet. And so if I go and look at my virtual networks, I've got my SharePoint auto VNet here. And this will show me all the VMs that I've got in that SharePoint VNet, including which subnets they're in. And you can see the DCs, everything's in the app subnet, but the DCs are in their own subnet here with these IP addresses. And by the way, the reason it doesn't start at 0 or 1, it starts at 4, is the first one you get, is because when I get to gateways, there's gateway machines that virtual machines would create on your behalf that get those first couple of IP addresses. So what I've done is created a virtual network, and I've assigned these VMs from my SharePoint farm to those virtual network subnets. And so that allows them to now inherit these IP addresses, and they can talk to each other. Now, I've got all of these in the same cloud service, but I could add VMs from a different cloud service to this virtual network, and then they would all be able to talk to each other using those IP addresses. There's no DNS today across cloud services, even when you've got them in the same virtual network, unfortunately. That will be coming soon. But if you want them to be able to resolve DNS names across cloud services, you'll have to bring your own DNS server. In the case of a SharePoint farm like this, that's straightforward because we already have a DNS server there, so we can then point those other VMs at that DNS server, and they will be able to resolve all the names of all the servers inside that virtual network. Let's talk about hybrid networking now, just really quickly. Hybrid networking is, like I said, important for those enterprise scenarios. I've got that SharePoint farm sitting up in the cloud, but I might be publishing to it from on-premise. And what I don't want is, even with ACLs are flaky, IP addresses can change, and I don't want that thing sitting out on the open internet, my publishing endpoint. I want to tunnel into it, that SharePoint farm, securely from my corporate network. We've got two solutions for that, like I said. One is point to site. So I want this machine to tunnel into that SharePoint farm. And let's see how I do that. This is really, really straightforward. The way that I'll do this is I'll say, hey, you know what? I want to tunnel into this virtual network. So I'm going to download the 64-bit VPN client. I had to do a few things, by the way, first, which I didn't show you, which is I had to create some certs and upload a cert to that VPN, that virtual network. I had to say, I want to get this ready for point to site, so I'm going to update a root cert that then I install on this machine here so that I can authenticate to that virtual network, that gateway that gets created on my behalf, and then be able to tunnel in. So that instructions for that are here. Create and configure a point to site VPN in the management portal. So steps, I've got to just run a couple of command lines here to create the root cert, and then create a cert for the VPN, and then upload the root cert. And then once you've done that, let's go back and, success, I downloaded it. Where is it? IE should pop up and tell me, hey, install this. All right, you know what? The problem is I downloaded this already, and it thinks that I already have it, and it's probably in my download folder, unfortunately. So I could go rooting around for it. Great. And we're given my lack of time to go rooting around for it. I think I'm going to have to not show you that, unfortunately. Yeah, so I apologize for that. IE's browser cache tripped me up there. But what would happen, it's really straightforward. Actually, did I delete it? What would happen is I'd run this app, and after a few seconds, what would show up is a new connection over here. You can see that I've already done this for another one of my VNets. I've got app VNet here. Let's see, app VNet, what I've got in there. I have any active VMs in there, and I can show it to you. Yeah, I think these front ends, are they active? Events web, so maybe I can just show you that real quick. So you say connect, it's just a standard remote access connection dialog. And if this works, I didn't plan for this, so I didn't even know those VMs would still be up and running. But if this works, I've connected, and then, oh, the firewall's on that thing. But, all right, so what would happen if I had time? I'd go disable the firewall, and then we'd be able to, oh, I think it's not going to work anyway because I don't have the firewall open. Oh, 3.1.8. Is that right? Yeah, I need to open the firewall. All right, so, but that's as easy as it is. And I'm now connected to that virtual network. Oh, okay. So anyway, nice for something to work for a change. So you can see that I'm now part of that virtual network, and I now can hit those IP addresses directly from my laptop, and that's point to site. Let's talk about site to site as our last virtual network topic. This one is when your enterprise IT wants to connect a part of your corporate network infrastructure up into Windows Azure. And that's useful for when you want to domain join VMs in the cloud to on-premise. In my SharePoint farm example, I've got just that. I've got 2 domain controllers up in the cloud. I've got another one on-premise. They're connected through a VPN site-to-site gateway that I've configured. And that is this Mr. VNet, SP Auto VNet. There's a point-to-site gateway. And you can see that here it is. Gateway's connected right now to a machine back at Microsoft. And this is kind of interesting because this SharePoint farm deployment's in Eastern and Western Europe, and it's got a VPN tunnel to a machine over in Seattle. So the connection's not the best, but let's go take a look at it. And what I'm going to do to show you this thing in action is to go to the term TS into one of these domain controllers. We'll get the IP address of the on-premise machine, which is in building 25, you can tell from the name, back at Microsoft. And I'm going to RDP from that domain controller in the cloud into that machine, which is actually a virtual machine, sitting inside a lab in building 25 through that gateway. And while that's happening, while we're getting that ready, let me just show you the quick steps for how I set up that gateway, because I need to configure a VPN device on-premise. And so there's a number of devices that we support. Juniper, Cisco, Watchdog F5 VPN devices that we've got scripts for that you can download and automatically configure those devices to connect to the VPN gateway in the cloud. And you can see the address of that VPN gateway in the cloud for this virtual network. It's down here. You can see it is right here. So that's the gateway address. That's one of the gateway virtual machines IP address up in the cloud, the public IP address for it. And we need to point our VPN server at it. And what I did is record me setting up remote RAS, which on Server 2012, now you don't need a hardware VPN device. You can use remote access server in Windows. And I've got a little walkthrough here of me setting up that, which is basically just going to the portal. So you can see here I'm on this machine. I open the portal. I say I want to download the configuration script. I pick Microsoft. It's RAS. So this is me setting up that VPN gateway that you see me running with. I download the script, I save it, I run it, and it's a PowerShell script. So I open it, I run it. Sorry, I'm just clicking through this. It's just this PowerShell script. You can say set private profile. So it's doing all the Windows RAS setup through PowerShell. running through the installation. Takes about 30 seconds, and then reboots the machine. And after I'm back, now I've got my gateway set up from my on-premise into the cloud. So here I am sitting inside, and I've actually connected to the gateway machine. So here's the building 25. I've actually got a whole bunch of nested RDP sessions here. So this is the domain controller. You can see the DCs there in the domain. It's got the 2 DCs up in the cloud as well as the DC on-premise. Then what I've done is I've gotten the address of the DC on-premise by pinging that. You can see it's 192.196.10.10. So I've RDP'd to 192.10.10. Here's that domain controller back on-premise, that virtual machine. So that's going literally halfway across the world, that what I'm just typed, which is pressed right there. Actually, I'm going 2 ways. I'm going all the way to Europe and then all the way across back to the US. And then finally, I've separately connected to the Building 25 server, which is, it's a Hyper-V server running this VPN virtual machine. So the VPN device is actually inside of a virtual machine. It's not even a physical machine. And then you can see the configuration right here. There's that gateway address that that VPN script set up for me. Okay, I'll take a question in a second. I'm just going to wrap up here. Now, you can see that I've covered a ton of ground really fast. I tried to go deep in some places. I wish I could have gone deeper, because really this is a 3-hour talk compressed into an hour and a half. And so I hope you managed to get something out of it, at least a flavor for what we've got. And I've covered deployment. I've covered how VMs get deployed. I've covered the storage architecture. Oh, by the way, I forgot to show you one thing about the storage architecture, and that is a demo that drives home just how any storage app can manipulate VHDs. Remember that 16 terabyte VM that I created with its VHDs? Well, I've got that storage account as storage west. There, it's expanding here. But what we're going to do is see the disks that I created with that PowerShell script sitting right there. And what I can do is say Control-C. Well, it's not going to let me copy it to on disk, but if I say copy, well, so if I say copy it to there, I've just copied it. Now, what did I do when I just copied it? What's a copy on write copy? Windows Azure Storage is sparse, and it also supports copy on write. So you can create snapshots of your blobs. I've just created basically a snapshot of the blob with this storage tool that doesn't even know it's working with VHDs. It just thinks it's working with Windows Azure Storage blobs. And I've created a copy on write copy of that VHD at that point in time. So I've covered storage. I covered high availability with availability sets, talked about fault domains and update domains. I talked about some networking features, the port forwarding, the load balancer, the custom probes, and then I've talked about point-to-site and site-to-site hybrid networking. I've also showed all of this in a highly available SharePoint form. And what I've got here is a poster that is the canonical SharePoint farm. This is a diagram of this poster. It's a little more complex than the SharePoint farm that I stood up, in that it's got each of these tiers in a separate subnet. So instead of having them all in one subnet, it's also got them, the domain controllers in a separate cloud service as opposed to in the same cloud service as the SharePoint apps and the SQL servers. Because most likely, if you're going to put domain controllers up in the cloud, you probably want to share those domain controllers with several cloud services, maybe a couple of different SharePoint farms or other applications up there. So that's this canonical architecture that we've got here. Am I an expert at setting up a SharePoint farm? No. How long did it take me to set up that SharePoint farm, do you think, that I just showed you? 2 hours? Really? Have you set up a SharePoint farm in 2 hours? Has anybody in here set up a SharePoint farm before? How long did it take you? 1 day? That's pretty good. Have you done it more than once? Yeah? Anybody else? Because typically, it takes several days of setting up the DCs. If it's new, setting up DCs, setting up the SQL server always on. You know, it's like take a break, go have some wine after you've dealt with all the problems that you run into, right? And come back, and after a few days, you've got a SharePoint farm. And I've never done it before. I just set up this one. How long did it take me? 4 hours. How did I do it? I did it using this. Oh, where is it? I did it using this right here. If you go to this web page, you will see that we've created a script for creating either a single VM, SharePoint app, SharePoint deployment, or a highly available SharePoint farm. After this comes up, networking's not behaving. But the highly available SharePoint farm, you specify a few parameters, and it's a massive PowerShell script divided into a few dozen PowerShell script files. You specify some configuration, like what you want the admin passwords to be, what you want the cloud service name to be, and then you just say go. And you come back, and a little bit later, the thing finishes. Here's a quick look at the PowerShell script. And it starts out with this master deployment, which all it does is this, auto-configure. And you specify the template name. I want the highly available one. And then the script folder where the scripts are. What auto-configure does, if you go to auto-configure, you can see the first thing it does here is sets up a storage account. If you don't, first, did you specify a SharePoint name? You can see creates one dynamically if you didn't specify one. Creates a storage account unless you specified one. Points at all the scripts, and then here it is. In Active Directory, SQL Server, and then SharePoint, and done. And then each of these, of course, is way involved. If we go to installing Active Directory, so there's the AD script right here is provision AD. There's provision AD. And the first thing it does is creates the VMs. And here's all the configuration for the VMs, the VM names, the service names, the subnets, the data disks, and then passes that to a separate script here that you can see is called ACDC deploy, which is sitting right here, which creates remote PowerShell, configures remote PowerShell, because we need to go hit that thing and install server roles in it from on-premise. So this all just runs automatically. I've saved the log file for this installation, and I've got it. Where is it? Oh, I've got it somewhere in here. Oh, maybe I just, no? Okay, well, I thought I had it. Anyway, just lost track of it. What the log file shows is just this thing spits out a whole bunch of logs as it goes on, including a starting timestamp and an end timestamp. That's how I knew how long it took, because I started at 10 o'clock one night, and I came back the next morning, and it had finished at 2 in the morning. So it took 4 hours. And voila, it was done. So that's what I want to leave you with. Now, the last thing I've got is this picture here. I've got a couple boxes of them, so you can take them with you. It's got the steps as well as this canonical SharePoint farm configuration, so feel free to come up and grab one. And I'm really sorry that I couldn't go a little bit deeper for you in the time that we had, but I definitely hope that you got a flavor for kind of the infrastructure as a service features we've got. Feel free to come up and ask me some questions if you want to, and I hope you had a good session and hope you have a great rest of SQL PaaS. Thanks very much. What's that? Oh, I've still